Here's the pre-calc lecture for 10.1.2, and it is going to be about the ellipse. So one of our conic sections is an ellipse, and it says conic sections are relationships that can be described using two fixed points called foci, or using one fixed point, a focus, and a line, directrix. So the one with the focus and the directrix would be your parabola. The one with the two, when it has two foci, then we're going to talk about, well, first we're going to talk about ellipses. So an ellipse does not have a constant radius, but it does have a constant distance. So I think, how are we going to do this? The book wanted you to go ahead and kind of derive the equation of an ellipse. So I wanted you to look at these and just graph them any way you could and then start noticing things. I think in this situation I better just I'm just going to give you the equation of an ellipse. Okay, so there it is. So H and K they do the same thing that they do to all of our other functions. An ellipse isn't a function, but the H moves would give it a horizontal shift, and K gives it a vertical shift. And A and B, well, I'll show you what A and B are as I graph these. Okay. So, and did I graph? I thought I graphed them. Let's see. I'm going to graph them. So this is A and B down here, and I see that there's no shift, there's no vertical or horizontal shift. So my center is going to be at 0, 0. And then this right here, A, this is A squared. So the square root of A would be 10. So that shows me that I'm just going to go 10 to the right and 10 to the left. I'm doing that on the x-axis because it goes with x. And then here I'm going to go, the square root of 16 is 4, because that's b squared. And then these are the vertices and the co-vertices. So an ellipse will have a major axis, which is the longer of the two axes, and it'll have a minor axis, which is the shorter one. And these are the vertices here, and then these two are called co-vertices. And we'll learn, and there's foci in here too that we're going to learn about. I might have to make a part 2 to this. But I'm just kind of showing you how to use the equation of an ellipse, and then we'll kind of study them a little bit. So this one, this tells me that it's x minus h, so h, I must have a shift to the left by 6 and up by 2, okay, because it's x minus h. So that's my center, and then this 36 tells me this is a squared, so a would be 6. So that tells me go to the right and the left by 6. 6. There's my vertices, and I'm supposed to go, oh, and then, okay, so these are actually my co-vertices, because see how this one's bigger, a bigger number? So my ellipse is going to be taller. It's not going to be the same as this one. The major axis and the minor axis, well, this one's going to have the major axis is y, and the minor axis is x. So anyway, this is 7, so go up by 7 and go down by 7. 1, 2, 3, 4, 5, 6, 7. And they always look lumpy unless you use graph paper. And even if you use graph paper, you have to draw it. You have to be a good artist to draw them nicely. But there's my ellipse. Let's do another one. Okay, so how you graph them is you look right here. This is H and K. So this tells me go up, or sorry, go right 2, and this would be down 7. So it's like I already started it, I guess. There it is. And then this is A squared and B squared. So A is going to be 3. So that means horizontally I'm going to go right by 3, 1, 2, 3, and left by 3. And then this is going to be 2, so go up 2 and down 2. My spaces aren't perfectly spaced, so this is going to look a little bit like a circle. Okay, so that's in general. I'm going to show you some nicer pictures. These are the ones out of the answer book, just so you can see that they're drawn a lot nicer than mine are. Okay, so that's how you can graph an ellipse. That's how the equation works. So that's what you were doing in 10.1.4. And then in 10.1.5, it wanted you to create an ellipse, and that's always fun, but it never works. When I do this in class, it never works. And I'm even going to do it right here, even though I know it's not going to work. But it wants you to get some cardboard and some push pins and some string and trace yourself an ellipse. So I don't have string, but I have some dental floss here. And I taped it down because I didn't have any push pins or cardboard handy. And what I'm going to do is I'm going to trace around. It never works with my with my string. And then it kind of gets a little crazy when I go around the corner here because I have to flip around. But I hope that, I hope that you could get the idea, of, after seeing this, you'll kind of get an idea of what it's supposed to be doing. The point of doing all this is that the whole time I went around, it's the same piece of string, right? Like the string, and I don't know if you noticed that it's attached right here and right here. I don't know if you can see that. That's where it's attached. So this length of the string is never changing. The length of the string is staying the same. So the definition of an ellipse is that the sum of, I don't know, let's call this distance 1 plus, we'll call this one distance 2. The sum is a constant because this string, it's not stretchy. So no matter where I go on my ellipse, the sum of the distance between this foci and the edge of the ellipse and this foci and the edge of the ellipse, if I add those, it's always the same number. And the number that it is actually, I don't know if this is going to blow your mind, but it's 2a, because if I say that the distance from the middle, from there to there, if I say that's A, and if I say this is B, the sum of the two parts of my string as I make it go around is 2a. And why is that? It's because, see when I go from here to here, see how my string, it's spanning from here to here, but then see right down here how it's like doubled up? It's doubled over itself. Well, from here to here, my string is like it's doubled. So this top part of the string, I could just like, I don't know, chop it off and stick it over here. And isn't that 2A? Because from here to here is A, and from here to here is A. So all the way across is 2A, and the sum of these two distances is also 2A, even if I, take it around somewhere else. So I think I spent a lot of time on that, so I'm going to come back in a video part 2 and do a couple more problems.